What we're going to do in this video, we're going to derive this very interesting formula here, which is an expression for the pressure exerted by an ideal gas using kinetic theory. Now, what we need to understand is the pressure on any given surface, right, is basically due to the collision of particles, air particles, on this surface. So we're going to try and calculate the pressure here, right? And so let's consider a single gas particle over here, m, traveling horizontally at a speed or velocity of vx, and it's just going to go back and forth, bouncing on this yellow surface at some periodic interval. So first of all, recall that pressure is of course force over area. And so let's try to figure out force first. Now for each collision, right, remember that this particle m is going to experience a change in momentum. And this change in momentum, let's figure it out. Right, so of course, remember that each collision is elastic. So it hits and bounces off at a velocity of minus vx. And so this change in momentum will be minus mvx minus mvx, which is minus 2mvx. Now, what about the time taken between the collisions, delta t? And so its speed is going to be constant. It's going to travel a total distance of 2L because it goes back and forth between collisions. And so delta t is simply going to be 2L divided by Vx. And so we can find the average force on this particle using Newton's second law, delta P over delta T. And this will become, of course, minus 2mvx squared over 2L, okay, which is minus mvx squared over L. And what we can do now, we can apply Newton's third law and say that the average force on the wall per particle is simply equal and opposite to this, which will be positive mvx squared over L. Okay, considering now that there are n particles, okay, then this will be n m vx squared over L, force by n particles, and finally the pressure on the wall, F over A, is n m vx squared over L times L squared, which is n m vx squared over V, the volume of this cube. Now we are almost there, and to basically what we need to do now is to consider that the particle travels in different directions. So there is a Vx, Vy, and Vz component. And if you want to aggregate all these speeds, what we do a vector trick. So we can say the aggregated speed, which we will call the mean square speed, is Vx squared plus Vy squared plus Vz squared. And because the particles in constant random motion, these components are all approximately the same. And so you can say c squared is approximately equal to 3vx squared. And so vx squared is approximately equal to 1/3 c squared. And so we're going to substitute this thing inside here. Okay, and what you will get, of course, is then 1/3 nm over v c squared. And so that's the expression for pressure on a surface using kinetic theory.